The title of the presentation is Link Prediction Techniques to Handle Tax Evasion. And I'm Jitin Matthews, who is going to give the presentation. Let's start with the outline of the presentation. I'll start with the introduction to the taxation system and then go to the different kinds of tax evasions that is being committed. And we focus mainly on circular trading. That's a work that we have done here. That is, circular trading is a kind of evasion. We made techniques to predict circular trading. And then we go, after defining the motivations and observations of circular trading, we go to the crux of the presentation, that is the model design for predicting circular trading. We give an overview of the methodology used and then define the data sets and the feature variables of the models. And we end with the results. Let's start with the introduction to taxation. Taxation can comprehensively be divided into direct and indirect tax. Direct tax, as the name suggests, it is paid directly by the consumer to the government. An example is taxes on assets like property tax, income tax, etc. And then comes the indirect tax, where the tax is collected by a third party and given to the government. Example is business tax or commercial tax. And tax payable is equal to the sales tax minus input tax. Sales tax is a tax that is collected by a dealer from when he sells the good to another dealer. And input tax is a tax that is given by a dealer when he is purchasing goods from another dealer. So in a sense, tax payable is a percentage of the profit that a dealer makes. That is, tax payable is non-zero only if there is a value addition in the business. And let's start with tax evasion. It is estimated that the state of Telangana loses around 20% of tax revenue per year. So if you consider the fiscal year, that is, if you consider the financial year of 2017-18, the total amount of tax revenue is around 40,000 crores. So around 8,000 crores is lost by the state because of tax evasion. And tax evasion can comprehensively be divided into tax avoidance and tax manipulation. Tax avoidance, in tax avoidance, tax is not even collected from the customer, or tax is collected but not reflected in the tax returns. And tax manipulation, they doctor the invoices. One example is bill trading, and then comes circular trading that we have worked on this paper. So let's see what is circular trading and what is the motivation behind it. So in circular trading, invoices are doctored. That is, there won't be any flow of goods as such, but the dealers will be creating or producing invoices just like that. And here, specifically in circular trading, the invoices will be circling around or cycling around without any value addition. You can see here, there is a dealer A, sells something to dealer B, then again it goes to dealer C, and finally comes back to dealer A to complete the cycle. And you can see that almost the same amount of goods is, the amount of goods is 18 some value, it also is 18 some value, so also is around 70. So value addition is almost zero here. The motivation behind this is to increase the company turnover for availing loans from banks and non-banking corporations, then to decrease the tax payable amount, that is to decrease the tax liability. Because if we increase the ITC, that is the input tax credit, then from this equation it's clear that the tax payable will be less. And they use this by using shell or dummy companies. These are the two motivations behind circular trading. Let's move to the observations that we got from doing an exploratory analysis on the data. So we see that most of the cycles that forms circular trading is of length 2 or 3. That is, 2 or 3 dealers are involved in this scam, and then the cycles are formed in a very short duration of the time, because there can be price fluctuations in the market. So in that case, if they do it in different days, this A to B and then B to C are in different days, then making the tax payable amount to zero is very difficult. That's what they do, right? There's no value addition. So in order to satisfy that, they have to do it in the same day. Most of the cases, it is on the same day. So It's an important observation. Now let's go to the crux of the presentation, that is predicting circular threading. Let's see the overview of the work. So the main observation that we have seen is that most of the circular threading happens because of 2 or 3 dealers. And our objective in this paper is to build classification models that predicts any plausible circular thread between 3 dealers. We are not taking care of 2 here, but 3 dealers. And such cycles between 3 dealers are called as triads in the literature. And the results is that logistic regression model performed the best among the 4 different classifiers, that is KNN, logistic regression, random forest, and SVM. LR worked best because we were able to give different cutoff values for the misclassifying cost, and that is defined in the future. So the benefit out of this work is that we were able to automate the process of detecting circular threading, and if we have a plausible list of evaders, it helps the tax department to take preventive measures against the scam. Because if the dealer is getting a notice that they are in the radar for future circular trade, there is less chance for them to go on with that scam. So yeah, that helps. So now let's see the data set. So we have seller, buyer, and here if you see the first row, it means that X sells something to Y in this time with an amount of 12,000. And we have used the first 2 quarters of the fiscal year 2015 of the state of Telangana for performing this work. And we transformed this database, sales transaction database, into a graph database where V denotes the vertex set, that is dealers, and E is the edges between them. And it is directed, and the weight of the edge is the amount. This amount is the weight. And we say that UV here, U to V is a potential edge if V to O and O to U is already formed. So we try to predict that whether this potential edge U to V materializes in the future. And this is the data set, the transformed data set, that is on which we are building the classification models. Here U to V, that is this UV, the potential edge that causing the pair, that is mentioned here, UV, the dealer name, and this is the intermediary node O, that is here in this case dealer A, dealer B, and the intermediate, the third part is C. So that is this O, that is C here. And then we have 5 different variables, which are the feature variables, and link, that is the dependent variable. One means the A to B edge is formed in the future, 0 means it is not formed. And we have created this potential, this data points, that is the potential triads, only if both VO and OU is formed in the same day. That's what we expect, right? It should happen the same day. So these are the feature variables. We start with Jaccard coefficient. The intuition behind Jaccard coefficient is that 2 dealers U and V collide to each other, then there is a high probability that they'll be having a lot of common neighbors. And this is normalized with the total number of neighbors. And flow ratio, that intuition behind this variable is that potential triads tend to have a huge number of high cache transactions from V to U via vertex O. So V to U via vertex O, a lot of transactions will be there, and a huge amount also. And flow count is the minimum number of transactions between V to O and O to U. Same for flow amount also. And 2 cycles is the total number of 2 cycles that is present in U. So U to V is the potential edge. So we will count the total number of 2 cycles that U has made so far. So because 2 cycles is a good indicator that 3 cycles also can take place. So that is the next feature variable. Then we have an interaction feature variable between Jaccard coefficient and flow ratio. And then the final one, which is a personalized PageRank. And here we start from a random vertex, and in each iteration we move to another vertex with a probability of 1 minus p, and or with the property of P, we move to randomly choose an edge, and in the PPR version, that's a personalized PageRank version, everything is same except that the gem is always made to a particular vertex. And QU is used for personalization. That is U, that is a source vertex. The value for that U will be 1, and all other cells in the vector will be 0. And A is the column stochastic matrix, pi is the PageRank vector, P is the damping factor, which is generally 0.085. And the motivation for using this is that the 2 cycles parameter defined before it takes care of 2 cycles between only for the vertex U. So what if you directly don't have any 2 cycles, but you might be having some neighbor or another neighbor's neighbor who are into 2 cycles. So we capture this information by going into the deeper levels of the network. And we normalize the PageRank matrix with the number of 2 cycles between Vi and Vj. A of ij is the normalized number of the 2 cycles, a normalized function of the 2 cycles between Vi and Vj, which you can see here. This is the Aj cycle of Vij, and this is the value here. This is the minimum number of cycles between Vi and Vj normalized. And the results are, we found that logistic regression worked the best among all the 4 with around 80% accuracy. This is because we can give different cutoffs, and so the misclassifying false stress is more costly than misclassifying genuine delays. Based on that, we found that LR is working the best here. You can see the LR mode is around 80% compared to the others. And then here, the p-value of the personalized PageRank is the lowest, which means that this is the most important feature. And then you can see the accuracy is around 80%, and the concordance value, which shows that how good is the model, is around 8.85, which is pretty good. And there is no overfitting, no underfitting. And yeah, ROC curve states that. Thank you.